Hey everybody, tonight we have kind of an unlikely or an unusual combination of what we call a floor function and a summation symbol. Okay, so let's just briefly review the floor function. It's sometimes called the greatest integer function because it returns an integer, the least integer or the greatest integer that's less than the input argument. So let's just use a concrete example here. Let's say 48 over 5. So 48 over 5, the nearest integer would be 45 over 5, which would be 9. Okay. Now, if this was the ceiling function, this would get sent to 10. Now, it may help to write 48 over 5 as the same thing as 45 over 5, which is known to be an integer, plus 3 over 5. That. Okay. Again, the math's easy just to do in your head, but it's called the greatest integer function because 9 is the greatest integer that is less than the input argument. It's less than by 3/5. Okay. Now, what's strange about this one is that we have a summation that has no dependency on the summation index. What that means that is this just gets summed up whatever these indices indicate. All right, now that's slightly tricky. Let's take a look at this fact that's very, very useful in resolving this summation. And I think I left something out right here. We need for m to be greater than maybe greater than or equal to n. I'm not sure. Maybe just greater than or equal to is probably okay. Yeah, greater than or equal to n, and the upper index, the upper limit has to be greater than the lower limit, I believe, for this to make any sense. It may work, I'm not sure. But anyway, let's just do it. Let's just do a concrete example of that. Let's say we had summation, let's say I equals 2 to 5. Now again, make sure you notice that this is a 1 here, so let me be very clear. That's a 1, and it has no dependency on the I, but that doesn't keep the summation from running, so to speak, okay? Now notice, though, that this would be equal to 1 plus 1 plus 1 4 times. And if you don't see that, just think of I being 2 right here, 3 right here, 4 right here, and 5 right here. Okay, so that's what you see this a lot in combinatorics where you have to add 1 sometimes just because of the endpoints, the way the endpoints work out. So that's why this fact is true. Okay, now let's move along. So you see that it really makes this problem fairly easy because this part right here is very routine. One of the properties of the summation is you can take this summand outside. It's just the distributive law. Okay, now so this would be the very same thing as let's just write this out. We can write this as 7 over 13. Now, using our result from up here, a lot of you just do this in your head, but just in case this is new to you, it's 7 over 13 times 387 minus 298 plus 1. Okay. And again, if you have experience with this, you don't need to go through all of this. But this is the very same thing as 7/13 times 90. And that's what, 630? 630 over 13. But folks, 48 times 13, I believe, is 624. So you would get 630 over 13. 48, if you divide, 630 over 13. 48 times 13 is 624, so this would be 48 plus 6 over 13. Okay. Of course, 6 over 13 is less than 1. Division algorithm guarantees that. And so you see, this was our summand, or this is the input to our original problem here, which is find the floor here. So this would just be equal to 48, which is the answer. Okay. Now, if this was the ceiling function, the answer would have been 49. Answer would have been 49. But again, this just comes from working out the arithmetic of the summation and getting this result, 630 over 13, which is equal to 48 plus 6 over 13. 6 over 13 is less than 1. And so that means the floor of this number has to be 48. So that's it, folks. Pretty easy problem, really. It's just working. This is kind of unusual to see something like this where you have the index of the summation. Normally this is some function. Normally this would be some function. We'll call it f of I if you want to. And here it is a function still. It's just a constant function. F of I is equal to 7 over 13. Okay. But I've seen people get a little confused if they don't see an I out here. It's not necessary. It's more common than this type of problem, which is what might throw some people for a curve. Anyway, that's the answer. Thank you for viewing.